This is Pre-Calculus, Section 5.1, Day 1 on the unit circle. We're going to begin talking about trigonometric functions. Trigonometric functions are defined in two ways, either in terms of real numbers, which is how we will be discussing them in Chapter 5, or they can be defined in terms of angles. And that's how we will be talking about them in Chapter 6. You will find that there is a lot of similarity or overlap between these two chapters because they both deal with periodic motion, which is a motion where a cycle repeats itself. The center of a unit circle is at the origin. So our center right here is at 0, 0. The radius has a length of 1. So that means that if we go 1 unit to the right, this point is going to be 1, 0. And if we go 1 unit to the left, this point on the outside will be negative 1, 0. If we go 1 unit up, this point will be 0, 1. And if we go 1 unit down, this point will be 0, negative 1. Again, based on the fact that the radius is 1. The equation then of this unit circle is x squared plus y squared equals r squared, which, since r is 1, the equation for the unit circle is x squared plus y squared equals 1. The circumference of the unit circle is c is equal to 2 times pi times r, where r is the radius of the circle. But since the radius of our unit circle is 1, then the circumference of our unit circle is 2 pi. For our first example, we want to show that the ordered pair 4/5, 3/5 is on the unit circle. I'm going to begin with the equation of the unit circle, which again is x squared plus y squared equals r squared. So in our case, x squared plus y squared equals 1. This ordered pair that we're given is an x value and a y value. So if that ordered pair is on the circle and I plug in 4/5 for x and 3/5 for y, it should make my equation true. So that's exactly what I'm going to do. Plug in 4/5 for x and plug in 3/5 for y, and I'm going to do a little bit of math. When I square 4/5, I get 16/25. When I square 3/5, I get 9/25. And now that I have a common denominator, I can add these two fractions together. 16/25 plus 9/25 is 25/25, which does equal 1. Since this ordered pair made my equation true, I just proved that it is on the unit circle. My second example is a little bit different. They're giving me an ordered pair, but this time I only know the x value of my ordered pair, and the y value is missing. So what I want to do is I want to start again with my equation for the unit circle. X squared plus y squared equals 1. I know my x value, so I can go ahead and plug that in. Square root of 3 over 3 squared plus y squared equals 1. And then I'm going to solve for y. When I square the square root of 3, I just get 3 upstairs. When I square 3 downstairs, I get 9. So that's 3/9, which is 1/3. So 3/9 plus y squared equals 1. Well, 3/9 is 1/3, right? I'm just going to simplify that. So now if I want to solve for y squared, I am going to subtract 1/3 over to the other side. When I do this, I end up with y squared equals 1 minus 1/3 is 2/3. So now if I want to solve for y, I'm going to square root both sides. Remember that anytime you square root, you get two solutions. So my two solutions are going to be y equals plus or minus. Now I need to simplify that square root of 2 over 3. I'm going to have to rationalize. So I am going to multiply top and bottom by square root of 3 over square root of 3, which is going to give me square root of 6 in my numerator and 3 in my denominator. But the question is, which one is the answer? Is it positive square root of 6 over 3 or is it negative square root of 6 over 3? Well, to figure that out, we have to go back to the beginning of the problem where it said that this ordered pair was in quadrant 4. And in quadrant 4, if we're looking for a y coordinate, we have to remember that in quadrant 4, y values are negative. So that tells me that it is the negative value here that is the correct y value. So my answer is going to be y equals negative square root of 6 over 3. Terminal points on the unit circle are determined by traveling a distance t, whatever that is, around our circle. Whenever we figure out a terminal point, we're always starting at the point 1, 0 on the unit circle, which is right here. And we go with a counterclockwise rotation if our t is given to us as a positive value. So basically, we move that way around the unit circle if t is positive. If t is negative, we still start at the point 1, 0, but then we're going to move clockwise around the circle for negative t values, which is a little bit counterintuitive, but when we talk about the unit circle, we're always moving in a counterclockwise rotation for positive measures. So we've got a couple of examples about terminal points on the unit circle. It says, find the terminal point on the unit circle determined by each real number t. So for our first one, t is pi. Well, hopefully you've been studying your unit circle and you remember that pi is located right here on the unit circle. So here's our starting point, and we're going all the way around to our ending point. And the question is, what is the ordered pair at that location? Well, the ordered pair right there on the unit circle is negative 1, 0, because remember, it's 1 unit to the left of the origin, and our radius is 1. The second one, our t value is negative pi over 2. Now we have a negative t value, which means that from our starting point, we are going to be going clockwise, not counterclockwise this time. Pi over 2 is a 90-degree rotation around the unit circle. So we're going to stop right there on the bottom. The terminal point right there on the unit circle is 0, negative 1. And then the last one is 5 pi. Okay, now remember, once all the way around the unit circle is 2 pi. So basically we have to go all the way around the unit circle twice, plus then we have to go halfway around or another pi units around again. I know I need to be starting at the point 1, 0, but so that I can draw this, I'm going to start a little bit inside here. So here's 1 rotation, and here's 2 rotations, and then I have to go 1 more pi. So my terminal point is going to be right there. And that is also the point negative 1, 0. So you can see that when t was pi for number 1, and when t was 5 pi for number 3, we ended up in the same spot. Therefore, we have the same terminal point. That happens often with the unit circle. So examples 1 and 3 show us that different t values can have the same terminal point. Let's determine the terminal point on the unit circle for t equals pi over 4. This point is on the line y equals x, which is right there. Here's our line y equals x. So we are looking for what is that terminal point right there on the edge of the unit circle. Since we know that this is the line y equals x, or this point, excuse me, is on the line y equals x, we're going to use that to our advantage, and we're going to start, once again, always goes back to our equation for the unit circle. So we're going to begin with x squared plus y squared equals 1. But since we know that y equals x, then we're just going to do a simple substitution. And we're going to say, okay, let's plug x in for y. So then this gives us x squared plus x squared equals 1. Well, now that we have an equation with just one variable, we can easily solve. Combine like terms, x squared plus x squared is 2x squared equals 1. Divide both sides by 2. This gives me x squared equals 1/2. And now I'm going to square root both sides of my equation. Okay, when I do that, and again, I'm going to have to rationalize at the same time. Okay, so when I do this, I'm going to multiply top and bottom by square root of 2 over square root of 2 to cancel that square root of 2 in the bottom. And I end up with x equals plus or minus square root of 2 over 2. Okay, now I have to think, where's my terminal point located? It is located in the first quadrant. So a little note here. Point is in quadrant 1. So x and y values both positive. Therefore, my x value is going to be positive square root of 3 over square root of 2 over 2. And the beauty of this one is, since y equals x, then that means that my y value is the same as my x value, or my y value is also positive square root of 2 over 2. This is a very common terminal point on the unit circle that we talk about all the time, and you may remember that from when we learned about the unit circle in our introduction to this chapter. So the terminal point then, if we're going to write our answer as an ordered pair, because technically it is, would be square root of 2 over 2, comma, square root of 2 over 2. So we found the terminal point on the unit circle for pi over 4 using trigonometry.